Hello and welcome to 5 Minutes of Postgres. My name is Lucas, and today I want to talk about two new features in Postgres 16. First of all, as of last Saturday, the feature freeze for Postgres 16 has begun. Now, no new features can be added to Postgres 16 without an explicit exception from the release management team. This also means that we're on track for a beta release sometime around the end of May, and hopefully the final actual Postgres 16 release roughly in the usual September to October timeframe. That, of course, is dependent on testing, and if you're eager to test Postgres 16, it's slowly a good time to start doing that. Maybe wait a few more weeks for a few things to stabilize, but we're getting close to the point where it's good to give the community feedback on the new functionality. There's two new features that I want to talk about today. First of all is updating the cost limit on the fly. This is a patch by Melanie Plageman that got committed shortly before the feature freeze. And what's great about this change is that it will help many people that run large production databases when they are in a pinch because of autovacuum problems. Usually when you have autovacuum configured, it can happen that your autovacuum cost delay is not aggressive. This was very common on older Postgres releases before Postgres 12, which is when the default cost limit was changed to be essentially 10 times as resource consuming, which makes sense on modern hardware. But even now on really large database servers, you might run into a problem where your vacuums can take hours or days. With this change in Postgres 16, the one thing you can do, which makes a huge difference in practice, is that you can change the cost limit setting whilst the vacuum is running, and the change will actually take effect right away whilst it's running. So you don't have to stop the vacuum and start a manual vacuum. You can actually get autovacuum to pick up that change and become faster, which when you close the transaction you wrap around because of some configuration issues of freezing, for example, then this really helps you avoid waiting on another vacuum run and instead just speeding up the one that's already running. I'm really excited about just having this as a tool when you need it, because then it really makes a big difference. Now, the other change that I found really useful was the ability to use two very commonly used aggregate functions in parallel query. Some background first. This is a blog post by Pavlo on the Cybertech blog, where he starts by talking about how aggregates in Postgres function. You can think of aggregates such as sum, average, max, or min. When you are running such an aggregate in parallel, what that means is that Postgres is actually able to break up the result set into smaller pieces. Instead of doing a sum across everything, it's actually able to do a sum of a part of the whole query, and then in the end combine it together. This so-called partial mode is a particular feature that needs to be supported for aggregate functions. If your aggregate functions don't support partial mode, you can't actually make use of this. And most importantly, this was true up until Postgres 16 for array agg and string agg. This commit that was added in Postgres 16 by David Rowley actually added support for these aggregates to become a parallel aggregate. Let's take a look at how this looks like in practice. You can just generate a test table, insert some data, and then in this particular case, we're making it very appealing for the planner to pick a parallel plan. What this ends up doing here, we're pulling data from this table and we're just grouping by one of the columns, and then we're doing a string aggregate and array aggregate on the other columns. What you can see here is that because of this new support for partial mode for these aggregates, now you can actually get a parallel plan. Previously, Postgres wouldn't have been able to do parallel plan like this. You can see first doing a sequential scan in each worker, then it's doing a partial hash aggregate in each worker, and then afterwards it's merging that data together. It's able to parallelize both the sequential scan and the aggregate function, which obviously can be a big performance difference because you're doing a lot of the work in parallel. On older Postgres releases, that is not the case. You would see the parallel sequential scan being in the parallel query, but the actual aggregate would happen outside of the parallel query after the results emerged. Obviously, in many cases, this can end up being slower. Overall, I'm really excited about Postgres 16. There's a lot of other things that got committed recently, and I'm sure we'll hear more about that in the next coming weeks. Thank you so much for listening. This was 5 Minutes of Postgres. Subscribe to our YouTube channel to hear about next week's episode, and talk to you next week.